Hey, so in this video I'm going to introduce a few more terms, but before we get to that, I want to review some of what we have seen already. So with the void functions, you can see in the main function, this is how we call the void function, and this is also referred to a function invocation. So you simply have the function name, the parentheses, and the argument list. So you pass, a list of comma separated arguments, and those have to match with the actual function declaration. Then also as a summary here, when it comes to value returning functions, you can see right at the top, the function call in an assignment statement, you have some variable name, and in this case I'm assuming that you have already declared that variable. So you set that to whatever that function returns. So again, you have the function name, you have an argument list, and you end that off with a semicolon. And you can see the next one is pretty much the same, but here we have a more complicated expression where you do 5 minus whatever that function returns multiplied by 20. Okay, and you assign that again to some variable. Okay, then you have another function call that we've seen in the previous video as well in some of the other examples where we do console output, and you can do a function call or invocation, and then whatever that returns is going to get put out to the console, for example, because that is simply going to return some variable, right, such as an integer or a float. Okay, then finally, which might be a bit confusing, is you can do similar to a void function. You can simply have the function by itself. Okay, so function name, maybe this prints something out to the screen that actually shows you, okay, I have invoked this function, and then so whatever value it returns will evaporate. So we will not actually use that. It will simply evaporate. And you can see it's kind of confusing. So if you want to do it, kind of use it in this way, use a void function instead. So you won't see this often because, again, it's not really very common. And so here we'll talk about the declaration and the definition, and again the call or the function invocation. And I'll introduce a few new terms here. So just like with a variable, you have to declare and initialize the variable before you actually use it, before you like print it out or multiply it, use it in some math, some expression. Now that's kind of the same thing with a function. So you can kind of compare it to how you are familiar with working in C++ already with variables. So right at the top here you have the declaration and the definition. So again you have the return type, the function name, and between the function body you can see we have some statements. Now the reason why this is the declaration and definition will become more clear like in the next slide, where you'll see we actually can have a separate definition. Right below this, typically in another function, you'll have the function call or the function invocation. As we've seen, you have some function name and you end that off with a semicolon. If it's a value returning function, in other words it's not void, then that is typically used in some expression, an assignment statement, or one of those statements, as I showed in the previous slide. Now what you probably notice here is the formal parameter list and the actual parameter list or the argument list. Again, in the function call or the function invocation, you have that comma separated list of arguments that you pass it in, and that is then copied basically or taken in by the parameters right where the function definition is. And that definition will then go and actually use, and compute by using the arguments that you pass it, and then it may or may not return some value back. So previously we've seen in the function declaration and definition right at the top here, we've seen that we have the parameter list. Now this is often referred to as the formal parameter list or the formal parameters. And then in the function call, you have the actual parameter list or the actual parameters. So I put it here as a list because it will be, one or more arguments or parameters or none. In that case, again, you'll simply have empty parentheses. But here you can see in the function call, you have the actual parameters or the arguments, okay, which you are already familiar with at this point. Now, one way of remembering this, you can see I highlighted the A right at the start of argument list. So the actual parameters, that refers to the arguments. So when you call or invoke the function, that is the actual parameters or the arguments, okay, that you pass the function, which again will then be copied basically or used by the formal parameters, which will be in the function declaration and in the function definition. Okay, so I hope these summaries here will make it easier for you to remember the stuff, maybe for your notes. Okay, next, adding another step to this. As I mentioned, you can have a declaration and a definition of your function, similar to how you can have a separate declaration statement and definition or initialization statement when it comes to variables. So where you define that variable, right, int x, is simply the declaration, but x is equal to 5. That is a definition for that variable. So x is now 5 or stores 5. So similar thing with functions. You can see right at the top we have the function declaration, and this is also referred to as the prototype. And similar to a variable declaration, you can see it ends off with a semicolon because this is a declaration statement. You have the return type, whether it's void or int or whatever else. You have the function name. Then between parentheses, you have the formal parameter list, against comma separated list of parameters. So this function you will call, as we've seen before, from main. Okay, and then main is the calling function. But as we've seen before, if the function is called in main, but we don't have a declaration right at the top, let's say we put the declaration following the body of main, then you'll get an error, because once it reaches that statement or that line in your code right in the main function, it doesn't know about that function. It has not been declared. And that's a similar thing that we've seen previously with variables. Okay, so it's important to remember that. So this is a way of separating the declaration or the prototype and the function definition out. You can have the declaration or prototype at the top, so before main, for example. Then you can have in main, you can have the function call or invocation, so this second section here. And then right after main, so following the body of main, you can have the function definition. You can see the line here, the return type, function name, and the formal parameter list. Those are the same for the function declaration and the function definition. The main difference is the function declaration or prototype. That line ends off with a semicolon. We do not have the body, so the opening and closing curly brackets with the statements in between. But you can see the function definition does have the body with the statements, and that first line with the return type, function name, and the parameter list, that does not end off with the semicolon as it does in the declaration. So you'll become used to this as you go along, and one way of remembering this is, of course, as we've seen before, the function body does not end with a semicolon, and the function kind of just ends when you hit a return or when you hit the closing curly bracket. But a declaration, again, is a statement. You are saying declare this function. So now the program will know when you reach that function call or invocation that this function exists, and it will know, like, when you actually use that function and give it arguments, it will know how to go and compute whatever it is that you want to compute. Before we move on, I'd like you to try and write a function that calculates and returns the greatest of two integers. So let's say it takes in 5 and 3 as parameters, then of course it will return 5. And I'm going to use this as an example in the next section. When we come back, I'll show you how I did it. Okay, so here is a quick example of how I can write this function. Now I gave it a really long name, get greatest of two ints. Can you want to have a function that is descriptive of what it does? This will get or return something. Okay, and then we have to describe what it is that we want to get. We will talk more about getters and setters in module 102, but in this case we want to get some value, so that is why I prefixed the name with get. You can see we have two parameters, and then here in the main function, you can see I simply do that function call or invocation in a console output statement. So what you could do is you could declare variables and then do console input and then pass those variables in here as arguments if you want to do that. But to keep it concise and just as a quick demonstration, I wrote it out like this. So if we build and run this, you can see we get 12. We have 12 and 7 here. Let's replace 12 with something like 5. Build and run that and we should get 7, because 7 is greater than 5. And as you can see, all I do in the function is we have those two parameters, x and y, and both are integers. And I'm simply passing again as arguments, I'm simply passing integer literals. So if x is greater than y, I'm going to return x, else I'm going to return y. So in the previous video, I mentioned that you can have multiple return statements. As you can see, I have two return statements here. So if x is greater than y, then it will execute this return statement. This will terminate the function and return x to the calling function, which in this case is main. So basically, this will get replaced by whatever x is. In this case, it will actually be y, because 7 is greater than 5. X is not greater than y. If you pass it in like this, so it will return y, which is 7, okay, right here, and we'll print that out to the console. Okay, so what I'm going to do now is I'm going to cut this out and then paste it down here. If I Control B to build, you'll see we get errors as we've seen before. So this is now the function definition. So when this is at the top here, right before we actually reach the function call, then it's both the declaration and the definition of that function. But because it's down here now, we need a declaration or the prototype up here, so that when it reaches this line, that it knows about this function. So basically what we can do is we can simply copy this header and then simply end that off with a semicolon, because this is the declaration statement for the function. This down here will now become the definition. If I build and run this, this should now work fine. You can see we get 7 again. We don't have errors or warnings, so this is fine. So a quick recap here, where you actually have the function call or invocation. These are the arguments or the actual parameters in the function declaration, and in the definition down here, those parameters are the formal parameters. So I'm going to do something a bit strange here. Okay, and this should give us more or less the same result if we remove this line. So if you don't have that console output. But as you can see, I'm calling it, in this case, similar to how you would call a void function, even though this will actually return that value. So it's going to print it out, but it's also going to return that value. You can do console output in functions as well, so you can see right here. So I'll just build and run this and see if this actually works. We should get 7. Yeah, you can see we get 7, that's fine. 12 here, and we should get 12 now, yeah. So as you can see, we don't actually get any sort of error in the error list or any kind of warning here either. But this is a bit weird because it returns that value. So if you want to do it this way, rather go and use the void function. Set that return type to void. Now if I go and build this, you'll actually see we get errors. So you want to change those to void, you want to change both of those return types to void. But the thing here is, those are now void functions, right? So we cannot go and return x or y here. But what we can do is you can still use return. So just the return like this. You don't return an actual value, you just have the return and end that off with the semicolon. And that will also terminate the function. So once it reaches that, let's say x is greater than y, it's going to print out x. Then it's simply going to return, or in other words, just terminate the function and return execution back to where it was previously. So then it's going to continue down here, right? So this should work fine now. Control F5 to run. And you can see this works, we get 12 and 7. It might be more useful to you to go and do console input, save those into variables and then put them into here so that you can just run it each time. But I'm trying to keep it as concise as I can here. So previously we looked at how you can write a function that returns the greatest of 2 integers. I'd like you to now try and write a function that returns the greatest of 3 integers. Go and try that now, and then when we come back, I'll show you my example. So for this, I'm actually going to undo a few times. So I'll set these back to integers, and I'll return x and I'll return y again. Now what I'll do is I'll copy and paste that. You can see we have these green squiggly lines that show up, and it says function definition not found. So I now have to go and define this function. So I'll scroll down, and you can go and do if-else statements, but another way you can do this is by actually using functions that already exist. So we already have this one function, so I'll just reuse that. And as I mentioned previously, you can use functions pretty much wherever you would use literals or variables. Well, at least value returning functions, right? You can use wherever you would typically use variables or literals. So what I'll do is I'll do greatest of 2 ints, then I'll do x. For the second parameter, I'll pass that function in again. Okay, greatest of 2 ints. As soon as you do the semicolon, depending on how you have your settings, it should do the formatting for you. And you can always go and left click and try and left click on the parentheses to make sure that you have all of your parentheses in. So you can see you can even pass a function as a parameter. You can see that is now an argument in this. This here is a function call. And within the parameter list, I'm passing x, which is another parameter. And then I'm passing a function for the second parameter of that function, which again, that function has 2 parameters, x and y. So that is going to return the greatest of those 2 integers. And then this function right here will then actually compare whatever that returns to x, and this function will then return that value. So that's one way of doing it. So it might be a bit weird, but if you take your time, read through this carefully, you'd see it's not that difficult to follow. Okay, so I'll go and use this function now. I'll just comment these out. I don't want that output to be confusing here. We'll build and run and we'll see what we get. We get 40. Okay, so that seems to work fine. So I can just test it a few times and that should work fine. So I wanted to demonstrate a bunch of things with this single example. You can call one function in another function. You can even call or invoke functions in parameters. I'm passing this function again as an argument within this function here, which is actually the same function. And you can see right up here, this makes it really easy to read now. We have these 2 declarations and we have the main function. The main function is very clean. We can see what functions we have available to us. Now, of course, you want to comment those, and I'll talk about that here shortly. And based off of these functions, we don't really care how they work behind the scenes. We just want to use those functions, to see what functions we have available, and we want them to be clean as well. We want our main function to be clean. We don't want our main function to be cluttered. Because of course we can have some of this functionality in the main function, but then we'd have many lines of code here in this main function. I also wanted to highlight the difference again between void and value returning functions. You saw that we can actually invoke a value returning function in a similar way to void functions, but again I recommend that you avoid that. It's kind of confusing. And I also talked about reusing what we already have, instead of having to go and write some complicated, if-else statement. You see, this is a couple of lines, and that is only 2 parameters. Now, of course, it could be shorter, have a bunch of comments in here and stuff like that. And if you take these out, and then you can take out the brackets as well, that will shorten it up. But this is just 1 line now. So many things that you can take away from this simple and this single example. So I hope that was useful to you. We'll move on to the next section now. Okay, another thing I'd like to mention here briefly is function declaration comments. So you have the precondition and you have the postcondition. So preconditions are basically conditions that should be met before the function is invoked or used. Otherwise it's not going to work, or it's not going to work, as you would expect. Then you also have postconditions. So if the precondition holds, these conditions will be true after the function executes. So of course the precondition needs to hold in the first place, and then you go and execute the function. So these postconditions are basically what will be true after the function executes. So what will happen basically. And for a value returning function, this will describe the value that the function will return. So of course these are comments. So you can see right here that you add comments to your function declaration. And these are done in two ways. You can see we have two examples. So this might look weird at first. That's because these are two different examples. So the top example, that first example, you can see I do not specify or write out precondition and postcondition. A lot of people do not write it out fully, right? You can see as a quick example here, arguments for x and y are integers. Now, of course, if you go and pass floats in here, then you can lose data. So that is why I wrote that just as a quick example. And so what does this do or return? Well, it computes the largest value, between x and y. So it's going to return the greatest value. Then example 2 at the bottom here, I actually write it out. Also, you'll notice that the comments are at the top of the function declaration. I prefer to write it like this, so example 2, mainly because it is consistent with everything else. So typically I write whatever comments I want to write in front of whatever that refers to. So if it's a while loop or a for loop, for example, or a variable or whatever, I want to do, then the lines, preceding that, I will go and write the comment. So again, I prefer this a second way, and I also prefer to write it out. So precondition and postcondition. Yes, it takes some extra typing, but then it's clear like what is what. So you can see the precondition here is similar to the first one. Arguments for x, y, and z are integers. Again, if you pass in floating point variables, those could lose data. So in these examples, it's kind of difficult because in the next module, you can actually pass variables or have parameters that will actually change or affect the variable that you pass in to the function, right? The arguments. So let's say I have a variable in the main function and you pass it in to some function. That function might actually be able to change that variable and things like that. Those are called reference parameters, and we'll look at those in module 1 or 2. But the point is it all depends on the function. So here it's kind of self-explanatory, so it might not be needed to have a precondition. And also you want self-documenting or self-commenting code. So in this case, these functions, in my opinion, don't really need comments, because you see you have get greatest of 3 integers. That is really the name of the function. So just from the function name itself, you know that you need to pass it 3 integers, and you know what it will return. It will get the greatest of those 3 integers. So because of this, you really don't need comments. It's fairly straightforward. Of course, it's not always the case. Sometimes you do need comments because not all of your functions will be this straightforward. That's another point that I wanted to highlight. You want code, or you want to write code that is easy to understand or obvious, to follow to a point where you don't need to write comments. Now, unfortunately, this makes some people lazy and, they don't write comments. But then you also have people that comment, each and every line, and each and every line that's very obvious. So the point is you don't need comments everywhere, but especially when it comes to functions where you need them, then this is more or less the format that you are going for. You can see that these are written along with the function declarations. So as you read your program, the file from the top down, you have these declarations before you get to main. After main, again, you'll have the definitions. So you won't go and write the function comments, these are preconditions and postconditions, where you have the definitions. You don't have to duplicate that much. You're already duplicating the header, and that's why for the most part with these simple programs I don't write it in this way. I simply write the the function once, right? Declare and define it before main. But if you do it in this way, then you only have a couple of lines to read before you read main, right? Because you can have many functions in your program, and then all of those can be defined like after main. Then a final question that you might have is, as you can see in the comment, I said arguments for x and y are integers. Well, that's great and everything, but what if I want this function to work with floats and integers and maybe strings or characters or whatever else I want to pass in here? Well, that's a bit more complicated. And in Module 102, that really is about flexibility. It's about how we can overload functions where you use the same function name, but the parameters are slightly different. It's also about flexibility in using templates, where, as I mentioned, you can use the same function but pass in, instead of ints, you can do like ints or floats or whatever you kind of want to pass in there, right? And you have one function that's flexible with all of the different types that you want to pass it, even custom types. We're also going to learn in Module 102 how to write your own custom types. So again, we're just getting started here, but these fundamentals are very important. So go and practice, and I'll see you in the next video.